Now we're going to finish off section 8.5 by going through some order of operations problem. Remember, that was the goal of this entire section. So as we're going through our order of operations, we briefly mentioned these previously in another section. Remember that our first step is going to be parentheses or other grouping symbols. We're going to work from inside to out. Our second step is going to be exponents. Exponents can sometimes include square roots. Then we are going to multiply and divide. When we're multiplying and dividing, don't forget that we want to work left to right. Right? So it may feel unnatural, but there are going to be cases where we're going to divide before we multiply. And then we're going to finish it off by doing our addition and subtraction, also working left to right. Or if you have a bunch of numbers, as we've seen in examples in previous sections, we can do some grouping of positive numbers and negative numbers in order to evaluate our addition and subtraction as well. All right, so let's start with example 3 here. So we're going to go through a bunch of different order of operations problems. And as we're going through these, try to kind of highlight each of our different steps. I'm going to show all of the steps throughout the process. As you're going through these problems, I strongly encourage you to use some scratch paper to show your work. So that way, if you do miss a sign somewhere, if you do make a small arithmetic error, we can figure out exactly where that happened. All right, so for A, we have 12 divided by 3 minus 6. So looking at our list of steps, we don't have any parentheses or exponents to worry about, so we don't need to worry about step 1 or step 2. Then we're going to go ahead and divide first. Right, we're going to divide first because multiplication and division come before addition and subtraction. Right, so we're going to divide first. 12 divided by 3 is going to give us 4. Right? So this 12 divided by 3 is going to give us 4, and what we're left with is 4 minus 6. Right? Then we're going to go ahead and evaluate this 4 minus 6. Remember, we're thinking about this as subtraction of our signed numbers. So technically these are different signs, so we're going to subtract. Right? We get 2. Our larger number is negative, so our result is going to be negative 2. Right? So we have a positive 4, a negative 6 gives us a negative 2. Again, remember, if you have trouble remembering these rules or keeping them straight, you can always throw dollar signs in front. Right? If we have $4, then we spend 6. Well, now we have negative $2. Right? We're $2 in the hole. All right, for B. First thing we're going to do is we're going to do parentheses. Right? So we're going to do 4 minus 16 first. This is actually very similar to our answer to example A. We have different signs, so we're going to subtract. 16 minus 4 gives us 12. Our larger number is negative, so we're going to get a negative 12. Right? And then we're going to divide this by our 2 squared. Right, now that we've finished with our parentheses, we are going to go ahead and do our exponents, because that's step 2. So we're going to evaluate 2 squared. So our negative 12 isn't going to change. Negative 12 divided by, well, 2 squared, right, is 2 times 2. 2 times 2 gives us 4. And then we are going to go ahead and finish this off by doing our division. Right, negative 12 divided by 4. We start by doing our dividing. 12 divided by 4 gives us 3. We have one negative sign, so we have a negative quotient here, a negative answer. Right, so let's look at example C. Right, so we are going to start by doing our parentheses. Right? So our first set of parentheses, we have 5 times 6. Well, 5 times 6 gives us 30. Right? We could do this in 2 steps. I'm going to go ahead and combine both of these into one step. I'm going to go ahead and take care of my other set of parentheses here. Right? So I'm going to keep my division symbol that's in between there. Right? And 4 minus 7. Well, 7 is the larger number. We have different signs, so we subtract. 7 minus 4 gives us 3. 7 is larger, 7 is negative, so we get a negative 3 here. Right, it's good practice to throw that negative 3 in parentheses, just because we don't want 2 signs directly next to each other. However, as you're working through on your scratch paper, if you forget some parentheses around your signs, it's not really that big of a deal. We just do it to make it a little bit easier to read. Right, now we're going to finish this off by doing our division. Right, 30 divided by -3. Well, 30 divided by 3 is 10. We have exactly one negative sign in our division problem, which means we're going to have a negative answer. So we get a result of -10. Right, for D, looking at this, we definitely have a little bit more going on in this problem. We have more numbers. We see some different symbols. This is an excellent example of our first step of our order of operations where we're using parentheses, and we may see more different types of grouping symbols. As we're doing these and we're thinking about our order of operations using our parentheses, we work inside to out. So the first thing I'm going to do here is take care of this center set of parentheses. Right, I'm going to copy everything else down on my problem as it hasn't changed. Right, so I still have a 3 out front. I have -6 plus 5. Right, and then in parentheses, -2 plus 7 is going to give us a +5. And then I'm going to close it off with our bracket. Right, it's a +5 because our signs are different. Our positive number is larger. Right, so -2 plus 7, we subtract, we get a +5. Right. Next, I'm going to keep working inside to out. So now I'm looking at these square brackets as my next set of grouping symbols. So we want to take care of what's in here before we deal with that 3 that's outside. In here, we have an addition and we have a multiplication. Multiplication comes first. So next we're going to multiply this 5 times 5. So we're going to keep our 3 out front. We have a -6. Plus 5 times 5 is 25. Right, now that we've taken care of our multiplication inside of our grouping symbols, these square brackets, now we're going to go ahead and take care of this addition. Well, this addition is really a subtraction because what we have here are two different sign numbers. Right, so we're going to take 25 minus 6, which gives us 19. Our larger number is positive, so we have a +19 left inside. Okay. Then we're going to finish this off by doing multiplication. Right. It looks a little bit different because we have multiplication going towards a square bracket. It's just like multiplying with a parentheses. 3 times 19 is going to give us a +57 for a final result to this problem. So if we have multiple different groups of grouping symbols, right? We're going to start from our inside, work our way out. Generally, your parentheses are going to be all the way on the inside. We're going to work out to square brackets, and then possibly more complicated grouping symbols as we go. Right, for E, right? Now we're going to look at, and we're going to start with our parentheses. Right? So starting with our parentheses, 6 plus 3 gives us 9. Right? So what we have here is we're going to do 9 squared. Right? In this particular case, this square root kind of also acts as a grouping symbol. We want to evaluate this. We want to evaluate the square root with our exponents. But before we do that, we actually have to figure out what's inside. Right? So I'm going to leave this minus sign out front here. But I'm going to go ahead and evaluate what's inside my square root. So I'm going to keep my square root symbol for right now. -4 plus 5, different signs, so we subtract. 5 minus 4 gives us 1. Our larger number is positive, so we get a +1 there. Right, now we're going to evaluate these exponents and square roots for step 2. Right, 9 squared, 9 times 9 is 81. Our square root of 1 is just 1, right? Because 1 times 1 is 1. And then we're going to finish this off by subtracting. 81 minus 1 gives us a final answer of 80. All right, for F, we have another square root here, which we're thinking about being in our exponent step. Again, we have a bunch of stuff grouped inside. So we're going to start with what's inside the square root first. We have an addition and we have a multiplication. Multiplication comes before addition, so we're going to do that step first. Okay, so I'm going to keep my square root. I'm going to keep my 24. So I'm going to have 24 and then a plus sign. 4 times negative 2. 4 times negative 2 is going to give us a negative 8. Right? Positive times negative gives us a negative product. We only have one negative sign in there. Right? Now we are going to go ahead and divide what we have inside. Excuse me, not divide. Add, subtract. Right? 24 plus negative 8 really means we're going to do a subtraction. 24 minus 8 gives us 16. Right? Then to finish it off, we're going to evaluate the square root. Square root of 16, again, we're thinking about our positive, our principal square root, gives us a nice positive 4 for an answer. Right? If for whatever reason we were to get a negative number inside instead of that positive 16, remember we want to answer it with not a real number because we cannot take square roots of negative numbers. We can only take square roots of positive numbers. Right? And when we're taking these square roots, it has to be a perfect square where something times itself, the same number times itself, gives us the product that's inside. All right. For G, we're going to throw in some absolute values here. Right? So what we're going to do is, to start with, we're going to evaluate what's inside this absolute value. So I'm going to keep my absolute value. 4 minus 6, different signs, so we subtract. Our larger number is negative, so we have the absolute value of negative 2. And then I'm just going to copy down this other one, our absolute value of negative 3. Right? Now we're going to go ahead and evaluate each of these absolute values. Right? Absolute value of a negative number, remember it's a distance. So if we have a negative number in there, our absolute value turns it positive. So absolute value of negative 2 is positive 2. Absolute value of negative 3 is positive 3. Right? We add these two together, two nice positive numbers. 2 plus 3 gives us a positive 5. All right, for our last one, what we see here, notice that it looks like kind of a big complicated fraction. According to our order of operations, we might want to go back and forth here, right? So we would want to start with our exponent in the bottom. But then depending on what we have, we could be going back and forth between our bottom and top, or our denominator and our numerator. And we don't want to confuse ourselves by trying to do that. So what we're going to do instead is we're going to think about these as being kind of two separate pieces. And we're going to evaluate each of those pieces to then get our final answer. Right, so I'm going to focus on my top part, my numerator. Right? And I have 3 minus 15. Right? Well, here we have different signs, so we're going to subtract. 15 minus 3 gives us 12. Our larger number is 15, which is negative, so we get a negative 12 for our result up top in our numerator. Right, then looking at our denominator, 4 squared minus 10. We're going to go ahead and do our exponent first here. 4 squared is 16. 16 minus 10 gives us 6. So we end up with negative 12 divided by 6. We're going to go ahead and divide. 12 divided by 6 is 2. We have one negative sign in our problem. So we have an odd number of negative signs, so we have a negative quotient for our result. So we get a final answer of negative 2 for this one. Right, so as we're going through our order of operations, we definitely want to be paying attention. We want to be using our sign rules from the previous sections. As you're going through, remember, you shouldn't be using a calculator to evaluate these. You should be working through them by hand. What you're writing down on your paper might not necessarily be as detailed as mine, but that's fine. But we still want to see some sort of work or thought process as we're going through these problems. Again, paying very careful attention to our integer rules as we go.